Plyometric training for judo. Aims. The aims of this presentation are to provide a detailed analysis of what plyometric training consists of and how it can be used to enhance anaerobic performance capacity in judo whilst providing relevant practical applications based on supported literature. Introduction. Plyometric exercises consist of an eccentric phase followed by an immediate concentric contraction, achieving maximal power production in the shortest time possible. This can be related to the stretch shortening cycle. This utilizes eccentric mechanisms shown to enhance the ensuing concentric phase with strength, power, and velocity. Firstly, the mechanical model demonstrates the function of skeletal muscle. The eccentric phase imposes muscular stretch, lengthening the series elastic component, storing elastic energy accordingly. At the onset of the concentric contraction, a recoil effect takes place, increasing force production. Relatively speaking, this same effect takes place in the musculotendinous unit. However, the tendons experience a level of stretch. Secondly, the neurophysiological model represents the stretch reflex of the muscle spindles. During eccentric stretch, the muscle spindles relay information through the type 1A fibers to the spinal cord. Impulses then travel back to the muscle fibers, stimulating high threshold motor units and causing a reflexive muscle action. The amortization phase, situated between the eccentric and concentric contractions, should be limited in time. If not limited to under a second, the benefits of the stretch mechanisms can be lost and the stored energy dissipates into heat, preventing stretch shortening cycle effects. Judo is a high-intensity technical sport involving gripping, grappling, and opponent throws. These require precise accuracy, strength, velocity, and power, primarily employing the anaerobic energy systems. A typical match can last seconds or up to 8 minutes. Therefore, the aerobic system is often used to maintain intermittent work and to accelerate the recovery process. A main attraction in judo is the ippon throw, a well-executed opponent throw which scores an entire point, consequently winning the match. This is performed from a standing position with a slight flexion in the ankles, knees, and hips. These joints extend and the hips and torso simultaneously twist to develop power. Acute and chronic effects of plyometric training. Researchers analysed the acute effects of high-intensity plyometrics on the special judo fitness test. This was designed to test the maximum number of takedowns an athlete could perform in 3 separate time trials. The results indicated that plyometrics can potentiate significant improvements in number of takedowns performed in the first trial through resistance to fatigue. This was achieved through drop jumps and at optimal heights prior to the test, which maximised neuromuscular activity. Another study compared the chronic effects of plyometrics versus a control. The control group showed no significant improvements in performance post of the 6-week intervention. Plyometric group, however, showed significant improvements in counter movement and drop jump heights, indicating that plyometrics can potentiate increases in power in sport-specific movements. Furthermore, the improvements were accompanied by significant improvements in rebound time and knee flexion angle, stating improved force absorption. Therefore, the subject increased eccentric strength and became less prone to injury. The drop jump is a common plyometric exercise used to overload the eccentric contraction and to develop vertical power. Coaches should enforce technical performance points such as parallel foot landings, accurate force generation, and reduce signs of valgus or varus to stimulate performance improvements and to reduce the risk of injury. Upon landing, foot positioning was not parallel. This means that force generation between the legs was unequal, leading to muscular imbalances. It's important in judo to have equal muscular capabilities because stances often change, but the requirement for power is sustained throughout. The drop rotation jump can be used to further the drop jump by developing rotational power of the hips and torso, which are crucial to perform opponent throws. Knee varus of the left knee could have been caused by mechanical overload. This can potentiate anterior cruciate ligament ruptures and tears. To avoid this, reduce the drop jump height. The incorporation of forward linear roll causes a balance distortion typically found in grappling situations which follow opponent throws. This heightens the difficulty of applying accurate power. The second jump trains the athlete to cope with balance distortion and to enhance accurate power generation. Horizontal force production was seen following the roll, suggesting an inadequate power generating capacity with applied accuracy. This may be because the movement was too complex for the athlete. To reduce this effect, break down the movement into phases to provide an element of simplicity. In summary, this plyometric analysis justified the use of plyometric exercise within a judo training environment. Furthermore, key coaching points were highlighted and the incorporation of plyometric drills into sport-specific movements were used. Coaches can use this to further their own athletes' performance, especially in judo.